Welcome back to the lab, y'all. We are here on a 2011 Chevy Equinox. In today's video, we will be discussing the IAT sensor and the MAF sensor, which is right here. And we will also be discussing the MAP sensor, which is right down there. This is the wiring diagram for our vehicle. As you can see here, we have the mass airflow and intake air temperature sensor combined together. That is why the sensor has more than 3 wires, because it is both of them combined. If you look here, you see the tan wire is a low reference or a ground for the air intake temperature sensor, and the blue one will be our air temp sensor signal wire. So if we look over here to these ones, we'll see this black wire is a ground. This is for the mass airflow sensor. The black wire is a ground, and the yellow wire is our sensor, is our signal wire, and this pink wire is going to be our supply. If you look at our voltage supply wire right here, which is this pink one, it is coming directly into the mass airflow sensor. And if we follow this down from where it starts, we'll see here that you have the ignition relay right up here. This provides power down through this wire. Everything comes down into this sensor. It's right here, this guy right here. Comes down into this sensor, where it then heats up an element and it allows the mass.
Here we have a more in-depth, closer view of the wiring diagram for the mass airflow sensor, along with a notebook paper describing what each of the wires and their colors represents. This blue wire right here is the 5-volt VREF for the IAT, and this tan brown wire is the ground for it. And right now we are reading, with the key on, engine off, we're reading around 2 volts. Alrighty, now we're going to be starting the engine. We're going to be key on, engine on, and Connor's going to be looking at the voltage of the mass airflow sensor through the signal wire at idle, and I'm going to hold the engine at 2,000 RPM, and then we're going to see what the voltage is of the mass airflow sensor at 2 grand.
So as you can see, the voltage hasn't changed a whole lot.
Want to bring her up to 2,000?
As you guys can see, it stayed at around 2.5 volts. So that means that this mass airflow sensor utilizes a digital signal. And that's when Connor switches his multimeter to hertz in order for us to actually be able to see what the mass airflow sensor is sending to the PCM. Now that we have the multimeter switched to hertz, it's actually reading something. So now we see that whenever the throttle is revved up, RPMs go up, the hertz goes up as well. And whenever you let go of the throttle, the hertz goes down. Alrighty guys, now we're going to see if the car will start with an unplugged mass airflow sensor. So we're going to unplug it, and now we're going to try and crank it. Let's see what happens. Alright, as you can see, the engine started with the mass airflow sensor unplugged. And that is possibly due to the fact that this vehicle is also equipped with a MAP sensor, a manifold absolute pressure sensor, and that could also be giving the engine some useful data, just in case anything ever happens with the mass airflow sensor. So yeah. So this is the circuit for the MAP sensor. The green wire is our signal wire. The gray one is our 5-volt VREF. And the tan looking one on the diagram is the ground wire. Alright guys, now we're going to be doing the MAP sensor, manifold absolute pressure sensor. It's right here, right above the throttle body. This is the vacuum line going to it. And it's got 3 wires. The green wire is our signal wire, we got that probed. The gray wire is our 5-volt VREF, and the wire in the middle looks like it's tan. It's a weird orange blackish color. That's our ground. So now, alrighty, right now we're just gonna confirm that our gray wire is our 5-volt VREF. So got the multimeter grounded, and all I'm gonna do is tap it to this pin. And we are reading 4.95 volts, which is good. And now we're gonna see if our MAP sensor, the sensor wire, is hertz or some sort of DC voltage. Guy got it hooked up to a jumper wire right now, and now I'm gonna just ground it out. And we are reading 3.9 volts, so I'm gonna assume that it's reading a DC voltage. So now Connor's gonna go inside the car and start it. And we're gonna see what happens. And it's changing. So I'm gonna tell Connor to rev it up. Rev it up. And as he revs up the engine, the voltage goes down. So I can safely say that this is indeed not a digital signal.
Alrighty, we have our PIDs menu up here. What we're looking at right here is we're looking at this MAF reading and this MAP reading. So if you notice, I'm gonna hit the throttle a little bit. Our calculated load right here should jump up to 100%, and we should see this number spike and then drop back down. So I'll demonstrate. So if you notice, that number spikes right before it comes back down. This is because the air is being pulled into the intake and pressure is building within the intake. Once that pressure then enters the cylinders, when the intake valve opens, that's why the number drops down, because the pressure is leaving.
Alrighty, we got compressed air right here. Our MAF sensor is open to the elements right now. So Connor's gonna go ahead and turn on the engine, look at the PID values, and I'm gonna spray in some air directly, bypassing the air filter and all that, and we're gonna see what happens. I know it's a little bit hard to notice, but looking at the RPMs, you can see when the engine stalls whenever I spray compressed air into the mass airflow sensor. Here we got the picoscope hooked up to the MAP sensor on one of the Buick Lucernes. As you can see, the square waves at idle are a little bit wider versus the square waves when the engine's revved up, and that's due to the fact that when the engine's revved up, there's more air flowing through the engine, which stabilizes the air pressure within the intake manifold.